A very good day to everyone. My name is Kwan, student ID AA16220, and today I am going to present my final year research project with title of Degradation Testing of Fibre-Reinforced Polymer Subjected to Underwater Environment. First of all, I will talking about the background of the study. In oil and gas industry, pipeline is important and has been widely used in high volume for transportation purpose of oil and gas over a long distance. However, it will still undergo degradation in the form of corrosion, leaking, or cracking subjected to underwater environment. There are two types of repair and rehabilitation pipeline method which are using conventional and FRP composite method. According to Lim and his gang, they are talking about the disadvantages of the conventional method. Conventional method is method by using steel sieve or steel cam, which are more suitable used on straight pipeline and has limitations on bend and joint. Besides, they are expensive, costly, and have safety issues doing hot work such as welding. Therefore, industry has discovered an alternative method which repair pipeline by using FRP composite. FRP composite are more cheaper, lightweight, applicable, effective, and its explosion potential is eliminated compared with conventional method. In problem statement, FRP composite is a material which act as load carrying and be used for rehabilitations of pipelines to prevent leaking. However, it will still undergo degradations that caused by environmental factors such as underwater. Because of the support data on degradations of FRP composite in salinity underwater scenario is insufficient, a degradation test of FRP subjected to underwater environment by imitating simulations where seawater exposure is needed to be conducted. There are two research objectives in this study. First is to study the effect of underwater environment toward mechanical property degradations of fiber-reinforced polymer composite over time. Second is to predict the remaining strength of FRP composite subjected to underwater environment over time. For scope of study, it is aimed to know how fast strength reductions of FRP composite subjected to underwater environment over time by using degradation tests and tensile tests. The material and apparatus we used in this study were fiberglass, and the chemical were resin and hardener. FRP roller will be used to remove the bubbles between the layers. This is the strain gauge and this is the emulsive cloth which used in the tensile test machines to record the remaining strength of the FRP composite sample after degradation. For sample preparations of FRP composite, we are using wet layout method. First, we will mix the resin and hardeners according to the ratio provided by the manufacturer. Next, we will pour the mixtures onto the fiberglass fabric by using scraper. Second layer is then placed on the first layers, and the aluminium roller is used to remove the air bubbles between the layers. The process is repeated until 4 layers, and last, we will cure the samples overnight in the room temperature of material lab. The methodology of this research study has divided into 2 stages. First stage was degradation test, and the second stage was material testing for mechanical property. Degradation test is undergone by taking the seawater from the launch product, as the photo shows here, and the sample will immerse into the container with seawater for 4 months and 6 month interval. Next, the sample will test and its physical property has analyzed. Then come to the end of stage 1. For stage 2 tensile test, the immersive cloth placed at the both ends of specimen, and the sample was grid by the dip of the UTM, and the stress strain data will observe and analysis. For result and discussion part, figure here show the graph of Young modulus versus time. We can get know that the stiffness of the degraded composite increased as the month increased. The stiffness was increased 9.62% in 4 months and 24.7% on the next 2 months. The increase of stiffness indicates the increase of the breadth of the sample due to loss of elasticity and deformation of the sample become neglected. The graph here has shown the ultimate tensile strength of the degraded FRP composites versus time. We can see the ultimate tensile strength of the sample has reduced 58% from its original strength, while the strength reduction after 2 months only 2%. This shows the strength reduction of degraded FRP composite samples is not distinctly and hence to be constant after 4 months. Control samples show progressive failures. Progressive failure of FRP composite indicate the different part failure surface of composite that reach failure stage are in different times. The progressive failure of control samples may fail due to crack of matrix before fiber. The photo here shows 4-month underwater sample, while the photo here represents 6-month underwater sample. And from the middle photo, we can notify that both of the samples have clear-cut failure pattern. Clear-cut failure pattern means the matrix and the fiber has filled at the same time. Goes to the conclusion part. Conclusion is used to answer the objective of this research study. For objective 1, the strength reductions of degraded FRP composite sample is not distinctly and hence to be constant after 4-month interval. The strength reductions for 4 months is 58%, while the strength reduction after 2 months only 2% in senility conditions. For second objective, the strength reductions of degraded FRP composite become constantly from 4 months to 6 months. This shows the remaining strength of composite would not reduce dramatically. Lastly, we talk about the significance of this research study. This study provided data on the level degradation effect on FRP composite for industry. Therefore, pipeline rehabilitations using FRP composite can be maintenance and service on time. Besides, FRP composite service time and lifespan data can be obtained. Information related to the remaining strength and mechanical property of the FRP can be gained. Thank you.